Good evening, everyone. This is Gunusundar. Today, I'm here to explain about my case study project, channel-wise distribution awareness, quantization of deep image super resolution network. My teammates are Pandian V, Gunusundar Reddy, and Lohit. Introduction: Super image resolution (SR). One fundamental computing vision takes target for the revenuing a given a low resolution input image to its high resolution concrete. Let's take a boost wide range of application including but not limited to the medical, satellite images processing, military surveillances, and the automotive industries give rise to the great amount of excellence from the computer vision community. Together together the interest from the community and rapid development of the deep natural networks, SR has recently witnessed the unprecedented of the breakthrough in the performance. Quantization has gained the popularity as one of the promising method to reduce the amount of required resolution of DNNS through the discreting the values of network weight, features of the gradients. Quantization has significantly reduces the computational loading while minimizing the accuracy less, and particularly on high level vision takes such as classifications, image, im- image super resolution conventional computing vision problem that increases the resolution of the image while restoring the structural details. Convocationally neural networks based on the approaches have been achieved a great performance improving in the field. However, CNNs require heavy computational costs and the memory of footprints. The great limits their applications on the resources constrained devices. To alternate this problem, recent works have focused on improving the model efficiency in terms of flops parameters and runtime by designing the novel lightness network accurates. However, these networks still consume a large amount of resources since convocational layers of the CNN operate in 32-bit floating point F32. Upon the observations, we propose the distribution awareness quantization. The performances of effective channel quantization, in particular DAQ, computes the distribution of each channel to determine the pre-channel quantization transformer. Parameters that adapt to each input adapt. The adaptive scaling approaches the facilities effective clipping of the outliers and the dominance of the quantization error. Network quantization. Network quantization is a promising research area that aims to map 32-bit floating point F32 values futures map and weights to lower bit or presections values. However, the quantization network usually suffers for server accuracy degrading. Many works tackles this problem was optimized uniformly or non-uniformly intervals between the quantization levels. The work focus on the quantization with uniform intervals. They can be accelerated in the hardware with sample arithmetic pipelines. Recently, researchers of the specialization, the precision of the each part of the network and learning the quantization method without the network retaining have been actively conducted. However, these approaches have focused on the semi-level tasks such as image classifications, which may be easier task for network quantization than SR, which requires the pixel level accuracy 35 to 43.
చెప్పేసాను monetization EDS. Quantizing EDSR, the proposed quantization method DAQ achieves higher PSNR with less resource consumption. Here the graphs. Channel-wise future map distributions of two distinct images in pre-trained reset on image classification task. Distribution aware quantization. Quantization function is a sequence of process that discretize a FP32 tensor to lower precision. General pipeline of quantization on a neural networks are proceed as following: input, feature, and weight are respectively called on to trigger range and then discretize. Then the quantizer convolution is performed with discretized in input with future of integer values and weight of integer values, and the convolution output is descaled back via D transformation, which is costly procedure for channel based quantization. Our proposed method follows a general pipeline of quantization method, except that as a standard deformation is replaced with our newly proposed efficient D transformation scheme. Overall, our DAQ convolution operates in a sequence of the following process:
Conclusion. We propose an efficient data effective quantization method for deep SR networks based on the observation that each channel of SR network has distinct distribution. We introduce a channel-wise distribution aware quantization DAQ method. However, channel-wise quantization with standard D transformation incurs a large computational overhead. Instead, we utilize an efficient D transformation by quantization parameters, reducing the computational cost of channel-wise quantization significantly. Our proposed scheme reduces the quantization error to a large extent, achieving high performance even without quantization tailored training. Evaluation of various SR networks demonstrate the outstanding performance of DAQ compared to the other concurrent methods with similar amount of resource consumptions. Thank you.